Okay, so let me move over to share my display. And I'm going to create a new notebook now for what is going to be the beginning of module 2. So let's do that. Create new Python 3 notebook. For this one, I am going to use a title and I'm going to say begin, or I'm just going to use module 2. Module 2, that's enough. That tells me that we're beginning module 2. Okay, that's a good enough name for my file. Remember, try not to use spaces in file names when you're working in remote machines. At some point, that will save you from some trouble, believe me. Okay, so now we're going to start on a markdown cell to take some notes. And this is the beginning of EngComp 2, our second learning module for this class. And in this module, we're going to learn more about manipulating data in different ways. First, we're going to learn a little bit of what is called exploratory data analysis. Then we're going to play a little bit with some basic statistics. And then we're going to learn a lot about different ways of visualizing data and making more beautiful plots with your data. And in the end, in fact, we're going to learn how to do widgets, which are plots in our Jupyter notebooks that we can interact with, and everybody loves widgets. They're a little bit of work to create, but when you finish them, you always feel a sense of satisfaction. So that's the promise for this new module. To be able to play with our data, we are going to need some fun data, and we found a data set that we're going to play with, which is some data of craft beers, canned craft beers that are found in the US. This is a data set that we found online, and we were lucky that the person who compiled this data posted it online and also posted it using what's called a public open source license, meaning the person who created this data is giving us and anybody else permission to use it in any way that we want and to create derived works. That is the philosophy of open source software. And we're always appreciative of folks who share code and data in an open model. This person posted that data and we thank them in the lesson, of course. Okay, so we're going to manipulate this data a little bit with NumPy, but we're also going to learn about a new library. We'll use NumPy, but we'll also learn a new Python library called Pandas. Pandas is a library for data analysis, and it's very, very cool. You'll see. So because we're going to use this new library, we're going to do both import NumPy and import Pandas. And that's going to give us all the goodness of Pandas to play with. We're not going to do a lot with Pandas in this lesson, but I will start slowly increasing in the next lesson. All right, so that's our first step, loading our libraries, our Python libraries to work with. And we're going to need to get the data into our local working directory. We put that data into a URL so you can remember. We have some library also that allows us to use Python to get files from the internet. And this is one that you might have to look up quite a few times until you learn it from a URL, lib.request. Import this function that's called URL retrieve. That is the function that we need. And then let's define a Python variable with our URL. I'm going to start a new tab here and type my URL to make sure that I have it correctly. It's go.gwu.edu/ and I have EngComp 2 for module 2, data 1, and there is the data. So it's correct. That is our data. With that URL, you can see here in this new browser tab what the data looks like, but we want, this is on the internet somewhere, we want to load that data into our local working directory, which is on Jupyter Hub, right? So we want, as we have for the other data sets, we want to add that data here somewhere. We don't have that data, we need it. Okay, so let's put that as the URL. It's a string variable that we're going to use in the function URL retrieve, the function URL retrieves once as arguments the URL and also a local file name. Let's call it beers. And I know from looking at it, this is a comma separated values, CSV, comma separated values. Okay, so that's going to be our local name for that. Once I execute that, you see I get a little nice output. If I had made a typo, I would have gotten an error, but I got some nice output. And now if I go back to my Jupyter Hub, you'll see that I have a new file. Here it is, beers.csv. And you can see that it was touched seconds ago because I've just downloaded this file from its location in a remote server to this. Well, this is another remote server in my Jupyter Hub. And now we have the data. The first thing that we want to do is have a little peek at it, look at the file. I mentioned before, but we haven't used it too much, but there's a possibility to do what we call shell commands, that is, commands that work in a terminal by itself and outside of Python with the exclamation mark. We call it bang. Exclamation point. And head is a command that allows you to take a peek at a file and look at the first few lines. So beers.csv, if I execute that, it's going to just show me the first 10 lines of the file. It's just showing that to me. It's not opening the file. It's not loading the file into my Jupyter session or anything. It's just showing that to me. And it's often a good idea to just peek at the file itself, although we did have it open here separately and we could look at it, so we know what it's in it. But inside here, this notebook, we've done that so that we get an idea, for example, about the fact that the first row of this file seems to contain some labels, and that's going to be important. Now, the next thing that we're going to use Pandas to read that data from the CSV file and save it into a new variable. We're just going to call it beers. And that's now going to be a Python variable. Beers is via the assignment operator. And now we're going to use a function from Pandas that is just read _CSV. Read CSV is a way for Pandas to read from the file, and we need to give it the file name, beers.csv, into a variable. This variable is called beers. Let's execute that. Okay, we've executed that, and we've created a new variable, beers. What type is beers? Beers is a Pandas core data type that is called a data frame. What the heck is that? Okay, I have some slides. Let me go to my slides for Pandas data frame. Okay, just 2 slides to show you what these are. What is a Pandas data frame? A Pandas data frame is like a whole table of data that is saved together into one variable name. And essentially, it's like a spreadsheet, the whole spreadsheet, just one sheet that is saved together into one variable name. One thing to notice is that the table-like data has labels in the columns and rows. Indicated in this slide is that the first row has the labels of the columns, and dot columns is the way that we can obtain those from the data frame. And on the left first row, you see a darker gray indicating that the first column contains the index of the rows, and we use dot index to obtain that from a data frame. That is the basic data type of Pandas that we have now available to us, and it's going to be much more powerful than what we've seen before. We've learned about lists, we've learned about arrays, and now we learn about the data frame, something that is a 2-dimensional table-like data with labels. Now, if we were to just grab one column of that data, that is called a series. The series is the column, but with its index. So that's also going to be important. Okay, that's just the illustrations that I wanted to use to explain what data frames and series are. Let's now play with them. So beers is a data frame. So if we were to just type beers, just the name, we obtain an output here that shows us this table-like data with, as you can see, labels for some of the columns, A, B, V, IB, U, ID, name, the style, American Pale Lager, that's the style, a brewery ID, ounces. Well, we knew from the source that these were canned craft beers, so that must be the amount, the volume amount in each can. And so you can see the first 5 rows, and then there's ... here in the middle, and then I'm being shown the last few rows, and then I get this output that says 2,410 rows times 8 columns. This is the size of the data frame in rows and columns. Okay, so that's interesting. We've got a two-dimensional labeled data structure with 2,400 rows corresponding to canned beers. By the way, we have a lesson here with everything written out that you should have handy. This is EngComp 2, lesson 1. Let me copy that and paste that both in my notebook at the top, and I will paste it in Zoom as well. Okay, that is the short URL to the written out lesson. And here's the link. And what I wanted to show you about that is that we have some writings at the bottom to explain what the column, what the labeling is for that data. The ABV column means alcohol by volume of the beer. IBU is something called the International Bittering Unit, which is some sort of description of the taste or the style. The ID is the unique identifier of the beer, the name, the style. Those are the ones we could figure out. So for that information, I'm going to just leave it there for exploring later. And here is our output. Now, what is interesting about DataFrames is that we have the ability to access this data using the labels. So for example, if we go back, you can see that I can use name, for example, of ABV is one column, right? I have the ability to grab a whole column using its label. How do we do that? For example, beers, that's the data frame with the square brackets just when we do indexing and slicing. But inside the square brackets, I can use the label ABV of that column. And out comes, as you can see, all the values of the column and the labels. So what do you think the data type of that is? Type of beers square bracket ABV, that is a pandas series. When we execute type with beers square bracket ABV, it tells us that it's a series. Now, it is what I showed in the slide before, a column of values with the label. Okay, so these are the two data types that Pandas makes available to us, the data frame and the series. And notice that now that we have a series, we can also do some slicing on it. So I could do beers. I could use first square brackets and the label ABV, and then use square brackets and a slice. So for example, I could go from 0 to 5, and this is just going to show me the first 5 entries of that column of data with the labels. Now, if you explore this data here, when we printed a whole lot of it, you will notice that in some of the row column entries, we have this thing called NaN. NaN means not a number. That just means that the person who created this data set left that empty, maybe because they didn't know what the IBU value of the sinister beer was. It was just not reported to them, so they don't have it available, and it was empty. This is also very typical in data that you have some empty values. And if you want to do computations with this data, these not a number things can be very pesky, because if you want to compute the average or the standard deviation or something, or plot those values, that NaN is going to be a pain because it's going to mess up your calculations. So one typical thing that we need to do is what's called clean our data, getting rid of those pesky NaNs. So what we're going to do is extract the two series corresponding to the ABV and IBU values. Let me annotate here what we will do. Notice I use the word series, which means column of data with the index corresponding to the ABV and IBU properties of our data set. Okay, then we will clean the data, and let me turn this into a bullet list with just a single dash and a space there. Let's add here the next thing that we're going to do, which is we will clean the data, which means removing empty values, which is shown as a not a number. And then we're going to save the clean data into NumPy arrays to play with it. Okay, that's what we're going to do next. So we're going to extract. When I say extract the series, it means we're going to do something similar to what I've shown here, beers, square brackets, and the label, but we're going to save it into a new variable, okay, so that we can do more things with it. Because here what we've done is simply display it for us in the output of that command, that code cell there. So let's save it. So let's save ABV series. We're going to create this new Python variable by assigning the beers ABV column to that. Notice if I do type ABV series, it tells me it's a series. I kind of knew it, and so that's why I named it series, but always a sanity check is good. We can also say, well, how long is this ABV series? And it tells us the number of rows in ABV series, 2,410, which is the same as the number of rows of the original data. And now we're going to clean it, removing the empty values using a pandas command for series. So I'm going to call this result ABV clean, and I'm going to use a method on ABV series that is drop NA. Drop NA drops the not A numbers. It drop NA is the name of this. And now, okay, well, nothing happened, but there's no errors. So what happens if we do len ABV clean? Tells me it's 2,348. So it turns out that it's quite a bit shorter. So a number, more than 50 values, about 60 values were removed from the original series by the drop NA method. It got rid of the pesky nans. Okay, so now remember that this is still a series. So type ABV clean is still a pandas series, but we can extract the values into an array using a pandas ABV, we're just going to call it ABV. That's going to be ABV clean. We're going to act on ABV clean and take the values property of that series. Dot values is just the values. Dot index would be just the index. And now this is going to return a NumPy array. So if I do type ABV, that is a NumPy array. Now we can do things with an NumPy array. We could, for example, take the mean. We know how to take the mean, and there are other things that we can do. But let's do the same thing. Let's repeat the process for the IBU. For IBU series. Okay, that means extract the series, get rid of the nans, they're not a number, and get the values into an NumPy array. Okay, so I'm going to create IBU series from beers. That's the two-dimensional table of data where there's a column with a label IBU. That column is going to be saved into IBU series. Let me add right here, len IBU series to output the length, the number of rows in that series, 2,410 as the original data. Nothing new there. Let's now do IBU clean is going to be IBU series dot drop NA. This is a method, so we need the round brackets. And let's see what the length is of IBU clean. I execute that and I get 1,405. So 1,000 values were missing from the IBU column. More than 1,000 values were missing from the IBU column. Well, that's how the data came to us. And what I have as an exercise now, a little short exercise, is the following. So we're going to take 4 minutes for me to stop talking for a bit, and you can do this exercise. Here it is. Let me make this larger. And me get my clock. I think 4 minutes is good. And let me stop the recording, pause the recording, and then come back to this screen.